So next topic, ultrasonic therapeutic system. So here ultrasonic therapeutic unit is one of the diathermy unit. So diathermy is nothing but heating, applying heat to the particular part of the body where you have to be treated. Okay, that is to be diathermy. So here the heat is going to be produced due to the ultrasonic energy. Okay, so the heating effect in this case is produced because of the ultrasonic energy absorption property of the tissue. So your body tissue going to absorb the ultrasonic energy. The effect of ultrasonic on the tissue is thus a high speed vibration of micro massage. Okay, so ultrasonic knowledge, that is nothing but sound signal which is going to be traveled with high speed vibration. Okay, to your body tissue, so which will be feeling like a massage, micro massage to the body. Okay, so the ultrasonic energy enables this massage to be carried out firstly to a greater depth than is possible manually, and secondly at times, that is in acute injuries, when pressure cannot be exerted by hand because of intolerable pain caused to the patient. That means if you do the massage by hand means manually, if you are doing the massage to the affected body or parts of the body. Okay, what will happen, it will not be giving that much effort, as well as it will create the pain for the particular part. Okay, when you will be using this massage in the injury time. Okay, so to avoid that, okay, to make over that disadvantages, you are going to use the ultrasonic energy, which will make the massage to be um, applied without any pain, okay, to the patient at the time of injuries. This is the advantage of using ultrasonic energy rather than your manual process, that is manually doing massage. The thermal effect of the ultrasound are dependent on the amount of energy absorbed, the length of the time of the ultrasound application, and the frequency of the ultrasound generator. So the thermal value, that is affecting value, will be calculated based on your absorption property, that is absorption of ultrasonic energy, and then time, how many how much amount of time taken to travel that signal to the body, other upper frequency value which is set in your ultrasound generator. Okay, based on that you will be getting the thermal effect for the body. This is the block diagram of ultrasonic therapy unit. Main voltage, and then it's connected to timer circuit to set the time, power and voltage control. So voltage and current value will be controlled here. And then half wave rectifier, full wave rectifier, which will be converting the signal, AC signal into DC signal. Okay, and then given to oscillator, which will be providing ultrasonic signal. Oscillator is nothing but it going to generate the ultrasonic signal, and then power amplifier will boost up the signal, and then given to piezo crystal will make the signal to be stabilized. Okay, constant signal will be provided by the piezo crystal, and then it will be given to the human body or parts of the human body where it has to be treated. So explanation for this block diagram is given. The heart of the system is a timed oscillator. So the heart of the entire system is your oscillator. which produces the electrical oscillations of the required frequency. Okay, which will be producing the oscillation, that is a waveform or signal, to which need to be given to the body parts. Okay, so the oscillator output is given to a power amplifier, which will be driving the piezoelectric crystal to generate ultrasound waves. A power amplifier uh, will receive the oscillator output, which will be driving the piezoelectric crystal to generate your ultrasound waves. See here, the oscillator output is given to power amplifier, which will be driving the piezoelectric crystal. Next, connected to the piezoelectric crystal, the power amplification is achieved by replacing the transistor in typical LC tuned Colpit oscillator by four power transistor placed in a bridge configuration. So the power amplifier is nothing but you can use the power amplifier as a LC tuned Colpit oscillator. Okay, so Colpit oscillator with the four power transistors. Okay, designed like a bridge manner will be giving you a power amplifier circuit. Okay, so power amplifier circuit you will be having oscillator with four power transistor, Colpit oscillator with the four power transistor in a bridge format, that is power amplifier. So the delivery of ultrasound power to the patient is to be done for a given time. So this ultrasound signal has to be delivered or transmitted to the body only for a particular time period. So that time period is controlled by timer. Okay, so timer circuit will helps to maintain the timing of the transmission of your ultrasound signal to the body. Okay, so the timer can be a mechanical spring loaded type or an electronic one. So timer has two types, that is mechanical type, electronic type. So mechanical na spring loaded type இருக்கும். Electronic one will be these two types will be setting the time from 0 to 30 minutes for the application of or transmission of ultrasonic signal to the body. So the output of the oscillator can be controlled by either of the following two methods. Okay. Using a transformer with a primary winding having multi-tapped winding and switching the same as per requirement. So you can control the value of or output of oscillator by two methods. That is, one is transformer method. So transformer which is having primary winding will be multi-tapped. Okay. In the diagram they didn't give. Okay, you imagine. So yeah, transformer, the primary commonly transformer will have two winding setup, that is primary winding and secondary winding. In that primary winding will be having multi-tapped. Multi-tapped means you will be taking the point to the ground or to somewhere else you will be connecting. That is said to be multi-tapped winding. Okay, and switching the same as per requirements, so based on our requirement or needs. Okay, so I need to give 20 minutes of ultrasound signal to the human body for producing the heat effect in the body. Okay, that means you have to change the winding setup, that is multi tap. So two tap needed or three tap needed or, so based on our needs or timing, we will be alternating the or modifying the circuit. Okay, transformer circuit. So controlling the firing angle of triac placed in the primary circuit of the transformer and thereby varying the output of the transformer. So second method, first method multi-tap winding. Second method you can control or you can place the triac. I think you all know what is triac. Diode, diac, triac. Okay. So triac will be placed in the primary winding of the transformer to provide the firing angle, okay, to control your output of transformer, which will be maintaining the oscillator output, okay. So the machine can be operated in either continuous or pulsed mode. So continuous signal as well as pulse signal you can use the machine. That means you can produce the output. A full wave rectifier comes in the circuit for continuous operation. So full wave rectifier will be used in the cases of continuous mode. Okay. So the main supply is given to the oscillator without any filtration. So without any use of filtering circuit, you will be directly applying the voltage, that is 230 voltage to the oscillator. The supply voltage is therefore at 100 hertz, which causes the output 1 megahertz to be amplified, modulated by this 100 hertz. So before giving to the what to say oscillator, you have to convert the main supply AC voltage into DC voltage by full wave rectifier or half wave rectifier. So after that only you will be applying the DC voltage to the oscillator, okay. So that will be having range of frequency as 100 hertz, okay. So the 100 hertz input will be given to the oscillator, but it will be producing 1 megahertz output, okay. So in pulsed mode, the oscillator supply is provided by half wave rectifier. So continuous mode la full wave rectifier will be used. In pulsed mode you are going to use half wave rectifier. So that the oscillator will be worked or enabled only during the half cycle period, that is half wave rectifier la half cycle la than output கிடைக்கும். So in that period alone you will be enabling the oscillator output, okay, so that you will be getting output 1 megahertz only at the first half of the cycle. That's why you are getting the pulsed waveform, okay. But in full wave rectifier, you will be getting for entire cycle, both positive and negative cycle, you will be getting the output. That's why it will be continuous. But here you will be getting only output at half wave, one half, that is positive half or negative half, based on the types of half wave rectifier you used. That is diode designed in the half wave rectifier used. You will be getting the output, okay. So whatever it means, either half wave, that is either positive or negative half cycle, will be producing the oscillator output, which will be looking like a pulse waveform, okay. அதனாலதான் இங்க ரெண்டு ரெக்டிஃபயர் கொடுத்துருப்பாங்க. பல்ஸ் மோடா இருந்தா it will be connecting to the circuit, will be connecting to half wave rectifier. If it is continuous mode, it will be connected to the full wave rectifier. So in front of the crystal lies a metal face plate, which is made to vibrate by the oscillations of the crystal. So before that crystal, okay, that means, so before the crystal you will be having the plate, metal face plate, which will be vibrating your oscillator output. The ultrasonic waves are emitted from this plate, okay. So the waveform with sound will be giving ultrasonic waves, okay. That's why they given that ultrasonic waves are emitted from this plate, that is metal face plate with the crystal, okay, piezoelectric crystal. So the crystal has a metal electrode pressed against its back surface by a coil spring. So the piezo, near the piezoelectric crystal, you will be connecting with your metal electrode. So metal electrode going to be placed in the uh, placed in the human body part, okay, to apply your ultrasonic signal. So voltage is applied to the crystal via this electrode. The front diaphragm is grounded and provided a return path for the excitation voltage. So the front diaphragm is nothing but which will be present at your piezoelectric crystal. So near that it will be used for returning path. Okay, returning path of your generated voltage in the uh, crystal, piezoelectric crystal. Okay, return path, another path. Then application technique. Here ultrasonic signal has several ways, several application technique. The probe can be put in direct contact with the body through a couplant provided the part to be treated is sufficiently smooth and uninjured. So directly we are going to place the probe to the part of the body where it to be treated. Um, this is one method so that you will not be getting injured. Okay, it will provide sufficient smooth and uninjured. Okay, so in case a long area is to be treated, so this may apply applicable for small area of the body. Okay, இதே long area வந்து நீ ட்ரீட்மெண்ட் பண்ணும் டயத்தர்ஃபினா, the probe will be moved up and down among the long area, and for small area it is given for a circular motion. Small area na இப்படி circular motionல உன்னோட probe move பண்ணாலே you will be getting the output. Okay, but for a long area coverage you will be moving the probe up and down. Okay, so it will not be suitable. That means it will not get the uniform distribution of the ultrasonic energy. Then dosage control. So how much ultrasonic signal have to be provided for the treatment. Okay, for particular parts. The dosage can be controlled by varying any of the following variables. So based on frequency of ultrasound, intensity of ultrasound, and duration of exposure, your dosage control will be maintained. Okay, so intensity, duration, frequency அதிக படுத்தினா dosage அதிகமாக இருக்கும். If you minimize this value means it will be dosage value will be minimized. Okay, if there is a wound or an uneven part, uneven part means joint. Okay, even இல்லைமா இப்போ ஹேண்டில் you are giving the therapy. Okay, that means in the hand from starting from shoulder to end of the finger னா எப்படி இருக்கும், ஒரு small first starting part will be very similar to each other, all the dishes will be same, but in between the finger, that is wristக்கும் ஷோல்டருக்கும் நடுவில் பார்த்தீங்கன்னா you will be having elbow. Okay, so in the elbow you will be having hard bones. Okay, so the movement of your probe will not be same throughout your hand. Okay, that is uneven part. இல்ல wound இருக்கோ, wound means any, what to say, wound என்ன புண்ணு, காயம். Okay, that treatment may be carried out in a water bath. So in that case you will be taking the treatment under the water bath. Okay, this is because of avoiding the mechanical contact with the tissue, which may damage an already injured surface. ஸோ இந்த டயத்தர்ஃபி யூஸ் பண்ணுறதுனால அன்இவன் பார்ட்ஸ் இல்லைன்னா காயத்தில் நீ யூஸ் பண்ணுறப்ப என்ன ஆகும், இன்னும் அதை வந்து டேமேஜ் படுத்தும் அந்த பார்ட்டை. அதை அவாய்ட் பண்ணுறதுக்கு யூ வில் பி ப்ரிஃபரிங் த வாட்டர் பாத். யூ வில் பி டூயிங் த ட்ரீட்மெண்ட் அண்டர் த வாட்டர் பாத். ஓகே, it should be ensured that air bubbles are not present either on the probe or the skin. Okay, air bubbles இருக்கக்கூடாது. For this treatment any vessels with warm water would be suitable. So you will be taking that water bath uh, in warm water. Okay, So the part of the body to be treated is rubbed with alcohol or soap. So before doing the therapy, you will be treating your body part with the alcohol, cleaned with the alcohol or soap. The probe is moved over the area to be treated, but held at a distance of about 1 to 2 centimeter from the area under treatment. Okay, the probe have to be moving at a distance of 1 to 2 centimeter. So this method not generally preferred because of the difficulty of controlling the exact amount of dosage. So dosage control problem will be very difficult in this method. So next we go for surgical diathermy. Okay, that's all about the ultrasonic diathermy. Maximum ultrasonic diathermy technique or types will be avoided because of dosage control problem as well as the physical damage to the part due to uneven or wound in the body.